Imagine, just for a second, descending way, way down below the crashing waves of the Pacific Ocean, down to a place so unbelievably deep that a single ray of sunlight has literally never touched it. We're talking about plunging nearly 6,000 meters down into the Mariana Trench. Down here, the temperature drops to near freezing, and you're surrounded by just absolute unbroken darkness. Welcome to This Explainer. Today, we're taking a vertical journey together into the deepest, most mysterious chasms of our planet to uncover exactly how life defies the odds in Earth's ultimate extreme environment.
Okay, let's dive into this. For decades, scientists were pretty much convinced that this extreme environment was completely inhospitable. I mean, they assumed that if you plunge up to 11,000 meters into total darkness, the conditions would just be way too harsh to support anything at all, right? But as we're going to see on our descent today, the trench tells a wildly different story. Survival here isn't impossible. It just requires some of the most alien, frankly mind-blowing adaptations on Earth. But before we actually start our descent, I want you to take a look at this number, 1,000. That's the number of atmospheres of pressure exerted by the sheer weight of the water at the very bottom of the ocean. To put that into perspective, that is more than 1,000 times the pressure we feel right now at the surface. It's enough raw, crushing force to instantly flatten a thickly armored vessel like it was a cheap soda can. So keep that massive crushing weight in mind as we begin our journey downward. All right, Section 1, the sunlit surface. This is the epipelagic zone, spanning from the surface down to about 200 meters.
This warm, vibrant layer is what we're most used to, and it sustains itself entirely on photosynthesis. Tiny phytoplankton capture the sun's energy, which kicks off this amazing, bustling cascade of life. From microscopic organisms acting as the grass of the sea, up to shrimp-like krill, and eventually to bigger fish, seabirds, and massive whales. It's a perfect cycle, but it relies completely on the sun, and as we go deeper, that sunlight doesn't stick around for long.
So, imagine we're in a glass elevator, right? And we're just now passing floor 200, meaning 200 meters deep. Notice what's happening outside the glass. The warmer colors of sunlight, those vibrant reds, oranges, and yellows, they're the first to completely vanish, just totally absorbed by the dense water. We are officially leaving the light behind.
Which brings us to Section 2, descending into the twilight. The mesopelagic zone, dropping from 200 to 1,000 meters down. And this brilliantly illustrates one of nature's coolest tricks, bioluminescence. As the darkness encroaches, up to 80% of all animals living in this realm produce their own light through specialized chemical reactions right inside their cells. You've got the lanternfish, which uses counterillumination, basically matching the faint light from above so they're completely invisible to predators looking up from below. Meanwhile, the anglerfish takes, a slightly more sinister approach, using a glowing lure to ambush unsuspecting prey. Because the deep ocean is technically the largest ecosystem on Earth, bioluminescence is actually the most common form of communication on our entire planet. How wild is that?
But hey, glowing in the dark isn't their only survival tool. Many species down here have evolved these incredibly oversized eyes that function almost like giant satellite dishes, just desperately trying to detect the faintest traces of light or the subtle shadow of a predator. Other creatures have gone the opposite route and evolved completely transparent bodies, letting what little light there is pass right through them. Down in the twilight, capturing light or being completely invisible is quite literally a matter of life and death.
As we hit the lower reaches of the zone, we meet an organism that honestly looks like an alien right here on Earth, the siphonophore. Now you might look at it and think it's just a really long jellyfish, but actually, scratch that, it's so much weirder. It's a living colony of thousands of tiny, genetically identical individuals called zooids, and they beautifully divide up the labor. Some drop stinging tentacles to catch food, defender zooids protect the whole colony from threats, and specialized ones exist solely to reproduce. Together, they act as one single, highly efficient, neutrally buoyant life form that is just perfectly adapted to conserve energy. Okay, our elevator is now passing the 1,000-meter mark. The pressure outside our vessel just hit 101 atmospheres. That means the dense, dark water pressing against the glass is over 100 times heavier than the air we breathe up at the surface.
Moving into Section 3, surviving the midnight zone, the bathypelagic zone, plunging from 1,000 to 4,000 meters deep. It is freezing, and it is pitch black.
So you're probably wondering, how on earth do creatures down here avoid getting instantly crushed by all that pressure? Well, they have to completely redesign their anatomy. They swap out those air-filled swim bladders that surface fish have for low-density oils and fats. They utilize super soft, watery jelly tissues that simply can't be compressed. But honestly, the most fascinating trick of all comes down to these tiny molecules called piezolites. These little guys act like microscopic scaffolding or support beams inside the animal's cells, literally preventing their membranes and proteins from collapsing under the immense weight of the water. And the really cool part for us up on the surface, scientists are actually studying these exact piezolites right now to figure out how to stabilize proteins for human medicine. Talk about a game changer.
Now, finding a meal in this unbroken darkness requires serious patience and, frankly, terrifying efficiency. Many creatures just conserve their energy and wait for what's called marine snow, which is basically just fragments of dead organic debris slowly falling from the surface. Yuck, right? But when live prey actually does come along, these predators do not miss. The gulper eel can literally unhinge its jaws 4 times its body width to swallow a meal. The black swallower, its stomach stretches to hold meals 10 times its own weight. And my personal favorite, the stoplight loosejaw. This thing projects its own private red light beam that its prey can't even see. It's basically acting like a deep-sea sniper in the dark.
But as we continue exploring the Midnight Zone, we run into this really fascinating biological mystery: deep-sea gigantism. Down here we find giant armored isopods, sea spiders with massive 2-foot legs, and of course the legendary giant squid. Now for centuries, the giant squid was considered a total myth. That is, until historical figures like Japetus Steenstrup, Moses Harvey, and Addison Emery Verrill scientifically documented their massive remains back in the 19th century. So it begs the question, why exactly do these creatures get so unbelievably massive in the deep?
Well, it basically comes down to a perfect storm of environmental factors. Up in the shallow waters, everything is moving fast. You've got high metabolisms, frequent predation, you gotta stay quick. But in the deep sea, there is extreme food scarcity, meaning a larger body is actually way better for storing energy. Plus, the near-freezing temperatures dramatically slow their metabolism down, meaning they grow very slowly over incredibly long lifespans. You combine that isolation, having very few natural predators, and a high level of dissolved oxygen in the water, and you get the absolute perfect recipe for slow, patient adaptations that yield literally 60-foot giant squids.
We are now plunging past 4,000 meters, folks. The crushing pressure outside our little elevator has climbed to a staggering 600 atmospheres.
Welcome to Section 4, the Abyssal Plain, or just the Abyss. This zone covers 4,000 to 6,000 meters. It's a totally flat, silent expanse that covers literally half our planet, and it's home to some really slow-moving anomalies, like the tripod fish, the rat-tail fish, and the super weird underside-feeding faceless fish. Because food is just so unbelievably scarce down here, an extraordinary event occurs whenever a massive animal, like a whale, dies and sinks to the bottom. Scientists call this a whale fall. First, you get scavengers like sleeper sharks and hagfish that come in and strip the soft tissue over several months. Then, these specialized polychaete worms and crustaceans settle into the nutrient-rich sediment left behind. Finally, bacteria take over, breaking down the stored lipids inside the very bones themselves, which releases chemical sulfides. This single sunken mammal can sustain an entire localized, thriving deep-sea community for decades. Plus, this whole process is absolutely crucial for the Earth's carbon cycle. It locks carbon away at the bottom of the ocean, which directly helps regulate the atmosphere we live in way up above.
And now, Section 5, the Mariana Trench. The Haddle Zone, pushing from 6,000 to 11,000 meters deep. This is the final, most extreme frontier, representing about 45% of the ocean's total vertical depth. Now, what's really interesting about this slide is that this trench was actually physically formed by some incredibly brutal geological subduction. Over millions and millions of years, the heavier Pacific tectonic plate has been slowly, steadily slipping beneath the smaller Mariana plate, literally dragging it down into the Earth's mantle. This immense, grinding pressure physically carved out the massive V-shaped chasms we know as the Mariana Trench, which houses the absolute deepest spot of all, the Challenger Deep.
You'd probably think there is no way anything could live at this absolute crushing bottom, right? Well, you'd be wrong. Scientists have actually documented microbial communities thriving right there in the trench sediment. They've also found these pale, translucent shrimp-like crustaceans just casually enduring the extreme forces. How on earth did they do it? Well, they've evolved this truly unique biochemistry that produces a special aluminum-based gel. This metal-plated gel actively coats and strengthens their exoskeletons, effectively turning them into tiny, uncrushable little tanks against the pressure. I mean, it is absolutely mind-blowing that biological creatures have essentially evolved their own metal armor to survive.
Looking back, our technological journey to actually reach these depths has been a long one.
Back in the 19th century, early sailors literally just threw weighted lead lines over the side of their boats to measure depth. By the late 1800s, the HMS Challenger was probing the dark with thousands of meters of cable. Then the 20th century brought sonar, bouncing sound echoes off the floor for exact precision. And then came the daring physical descents. Jacques Piccard and Don Walsh reaching the Challenger deep in the Trieste back in 1960, and James Cameron's famous solo dive in the Deep Sea Challenger in 2012. Looking ahead, there's actually a major international goal to produce a complete map of the entire ocean floor by 2030.
But we really have to remember that despite all this incredible history, only a tiny, tiny fraction of the ocean has actually been seen by human eyes. The future of deep exploration isn't necessarily just throwing humans in submarines anymore. It's all about robotics. We're talking remotely operated vehicles, unmanned underwater drones, and these long-term seafloor landers. They can stay down way longer, dive even deeper, and safely gather the vital data we absolutely need to understand Earth's climate cycles and tectonic movements.
Which brings us to the ultimate question. If we've already found things like gulper eels, giant siphonophores, massive 60-foot squids, and tiny metal-plated crustaceans in the super tiny fraction of the deep sea we have explored so far, what else is down there? What totally unknown ecosystems, completely unfamiliar species, and hidden geological processes are silently waiting for us out there in the vast, endless darkness? The abyss is out there, folks, covering half our world, just waiting to be discovered. Thanks for joining me on this explainer, and keep your curiosity deep.